Our second area volume question is from the 2015 exam. It was question number 2. It is a calculator active question. I'm given two functions, f of x and also g of x. In part A, I'm asked to find the area of regions R and S added together. From the graph we see in region R, G is my upper curve and F is my lower curve. The red is on top, the blue is on the bottom. But as soon as I move past that intersection point, now when I'm in region S, the blue curve is on top and the red one's on the bottom. Because the upper and lower bounds switch across that intersection, that means I need to do two integrals, one for region R and one for region S. So I'm going to find what that intersection point is. So use that function on your calculator to find that x coordinate of 1.0328. Write it here on your paper, and I would suggest you store it into a dummy variable. If we're going to call it a further on in the problem, then you must have it defined as a up here. To find the area of region R, my lower limit is a 0, my upper limit is a that I have here, and it's g minus f. And for my region S, I'm going to begin at A, and that goes until an x coordinate of 2. So my limits are from A to 2. And on that one, F is my upper curve. So my upper minus lower is F minus G. I would highly suggest that you call them, that's my tip here off to the side, that you call them F and G. You can write out the actual expressions for the functions, but it takes a while to do. You run the risk of forgetting to put parentheses around something or doing a copy error, which would cost you a point. So the easiest way is just to call them by name, and they're already defined for you. So that's your best route. And then to put them into the calculator gives you the answer 2.004. You get 1 point for correct limits on these. You get 2 points for the integrands being in the correct order, and then a point for that final answer correct to 3 decimal places. In part B, I have region S as the base of a solid whose cross sections perpendicular to the x-axis are squares. There's some important information that I'm pulling out of here. First is the x-axis tells me my integration is with respect to x. Squares gives me that area formula that I'm going to integrate. So I'm starting with the area of a square formula. And when I look up here at region S, I can see that my upper curve is F and my lower curve is G. So my side is defined by F minus G. And then I square it because that's how you find the area of a square. This is what I'm going to be integrating. I pull that back into my problem. My limits are going to go from my low x of 1.0328 to my high x of 2. I've already defined it in part A, so I don't need to define that again. I can just pull it down from that part. And then f minus g quantity squared. You get 2 points for that correct integrand, and then you get 2 points for the correct answer. In part C, we're told that h is the vertical distance between graphs f and g in region S. So when I look at my graph here, I'm focusing on region S, and that vertical distance is just given as f minus g. So I first just define f minus g. And the question goes on to say, find the rate at which h is changing. That just means to find h prime. So I start over here at h of x is f minus g. To find the derivative of a difference, I just find the derivative of each one of those terms. And then I have to evaluate this at x equals 1.8. So then my x's just turn into 1.8s. And then you just put that into your calculator. If you have f and g stored into your calculator, you're just going to use that derivative function in your calculator to calculate these derivatives to come up with these final answers. Either negative 3.811 is your truncated answer, and negative 3.812 is your rounded answer. Point-wise, if you have this derivative written out in its general terms, you get a point, and either one of these answers would earn the second point.